Okay, so the teacher has given you a table of values for x and y, and they've asked you to find the rule. Now, you can do things like guessing and checking and whatnot, but the first thing I would be doing is checking to see if the function for the function table is linear. Now remember, a linear function is of the format y is equal to mx plus c. So it's something multiplied by the x, and then we're adding something else onto it. So in order to see if this function here is linear, what we need to do is find out if there's a similar difference between each of the values. And we can really see, looking this way, that we're going up by 1, that's a change of 1. That to there is a change of 1, so 0 to 1 is a change of 1. 1 to 2 is a change of 1. And 2 to 3 is a change of 1. Okay, so each of these is changing 1, and then if we look at the bottom, each of these is changing by 5. So to get from 3 to 8, it's add 5. 8 to 13, add 5. 13 to 18 is also a change of 5. 18 to 23 is also a change of 5. So if you're going up in ones on the top, or for the x value, and you have a similar change in the bottom, then you have definitely got a linear function. And this change in the bottom is your m value. So now what I know is that this function is going to be 5x plus something. So that 5 tells me that instead of an m, we can write the 5. So now we need to know what that plus is. So if we just take any of the points, let's take this one, 0 and 8, we can substitute them in. So we've got 5 times 0 plus c, and we know that the y for this is 8. Now 5 times 0 is 0. So that's telling me that c must be 8. So my function for this table is y is equal to 5x plus 8. It's linear, and this is a rule. Now all you need to do is check it. Let's check the last one here, so the 3 and the 23. If we did 5 times 3, we would get 15, and 15 plus 8 is 23. So we know this is our function. You can obviously check everything in your table, but we know this is the case. Okay, now it's a little bit harder when you don't have the change in 1 up at the top to find out if the bottom's the same change. Now this one is actually changing the same up the top each time, but let's just take an example looking at these values here to see how we might find what m could be, and then move on to see if this is linear. So the change in x on the top here is 4, and the change in y on the bottom here is 20. So if we find then the change in y and we divide by the change in x, we get 5. Now this is actually what our m is going to be. So we're guessing that we have 5x plus c. So this is where we're going to start our guessing. It's like an educated guess, I guess. So looking at the 5 and the 16 then, we know that y is 16, and we have 5 times and x is 5, and we can work out what c must be. So 25, get back to c from 25, we need to subtract 9. So c is going to be minus 9. So this is our guess. It's an educated guess for this table. We've got 5x minus 9. Now what we want to do with our guess is to see if this actually works. So let's have a look at 1 and the minus 4, and we would just plugging it in, we've got y is equal to 5 times 1 and then minus 9. Y is equal to, so 5 times 1 is 5, minus 9 would be minus 4. And this is the actual value of the y on our table. Now you need to check everything because it might work with two things, but it needs to work with all of your values in your function table. So having a look at the 9, if we had 5 times 9 and then minus 9, so 5 times 9 is 45 and minus the 9 is 36, so that one works. And our last one there is the 5 and the minus 3. So we've got 5 times minus 3 minus 9. So 5 times minus 3 is minus 15. And minus 15 minus 9 is indeed minus 24. So this function, the 5x take 9, works for all of them. Now, if you do your change in a y and you divide by the change in the x to find your m value, but it doesn't work for everything, then perhaps you don't have a linear function and you need to start guessing some other things. But that's another video for another time. Thanks for watching this one though.